Welcome to our physics class. Today we are going to discuss about a optical phenomena that is called as total internal reflection. This is a particular phenomena which happens when the light is trying to travel from a denser medium to rarer medium. For example, light is trying to pass from water to air or glass to air. In such situation, there is a special optical phenomena that is called as total internal reflection. So first we will discuss what it is. Now you consider you have a denser medium. So you have a denser medium. Denser medium means it is optically denser. That is, if this one is having refractive index n1 and this is having refractive index n2, then refractive index n1 is greater than n2. This is optically denser medium. So the light is going from this medium to this medium, that is from the denser medium to rarer medium. You think in such a way that our source of light is here. So if the source of light produces a light and this is going towards this side, like this. So this is the ray of light. So you know, when the light is moving from a denser medium to a rarer medium, it will bend away from the normal. So if the normal is like this here, then it is obvious that it will go like this. It will bend away from the normal. This is the normal situation. Now you think if it is moving with an angle which is the angle is more than this one. So our angle of incidence is this one, IC is this one. Now if the IC is increased a little bit, in this situation, what will happen when this IC is increased? Naturally this angle of refraction also will increase. This R also will increase. Now if you increase it again and again, what will happen? At a particular situation, the angle of refraction will become 90 degrees. So that point is very, very important. That is, you think about a particular angle of incidence for which the angle of refraction is 90 degree. Your light is moving parallel to the surface itself. So this angle of incidence, that is called as critical angle or IC. So the main point is, if a ray of light is falling from denser medium to rarer medium and the angle of incidence is critical angle, then the angle of refraction will be 90 degree. Further, if you increase, what is going to happen? If you again increase the angle of incidence, this refraction will not take place. Only reflection will take. That is 100% of the light will reflect back to the denser medium itself. That is, if the angle of incidence is this angle is our I, which is greater than critical angle IC, then the entire light will reflect back to the same medium. That is called as total internal reflection. Now for easiness, I will erase the other thing. I am erasing this one. So the total internal reflection will look like this one. What I will keep, which is making 90 degree. Okay. So this is making 90 degree. This angle is IC. So here what are the things you have to remember? The first thing is, in order to take the total internal reflection, there are two conditions. The first condition is the light should try to pass from denser medium to rarer medium. That's the first condition. That is, light should try to pass from denser medium to rarer medium. That is the first condition. Second condition is the angle of incidence should be greater than angle of the critical angle. The angle of incidence should be greater than the critical angle. When these two conditions are satisfied, the total internal reflection will take place. So what is total internal reflection means? That is, when the angle of incidence is more than critical angle, refraction will not take place. The entire light will reflect back into the same medium. That is called as total internal reflection. So that's about the total internal reflection. Now the conditions, physical conditions we already discussed. Now if you think about the angle, what will be this critical angle for a particular situation if you want to calculate that one? If you take the refractive index, what is our refractive index? Sin I by sin R is equal to n21. Sin I by sin R is equal to n21. This is our Snell's law. Now for this particular situation, What is our angle of incidence? Our angle of incidence I is equal to IC. That is, I am talking about the critical angle. When I is equal to IC, what is our R? R is equal to 90 degree. That is, at critical angle, angle of incidence is critical angle means angle of refraction will be 90 degree. So for that particular situation, how we can write? Sin IC by sin 90 is equal to N21. Or this sin 90 is 1, or we can write sin IC is equal to N21. So using this equation, sin IC is equal to N21, you can find out what is the critical angle. How you can find? Just opposite of that one, that is IC will be equal to sin inverse of N21. If you take that one, you will get the critical angle for a particular medium. So this is the theoretic part. But for the examination, when this is coming, most of the people will make a mistake in this one. Because if they are asking find the critical angle for a glass for which the refractive index is 1.6. If you take IC is equal to sin inverse of 1.6, generally people used to write like this. But you know, for sin theta value will not come more than 1. So such a situation is not possible. Here the mistake comes. See here N21 means it is the refractive index of the second medium with respect to first medium. That is, second medium is air, first medium is our glass. So in that case, what you have to do? You have to write refractive index, this IC is equal to sin inverse of 1 by N12. This IC is equal to sin inverse of 1 by N12, because the value which is given, that is for the glass, that is N12. So that mistake you should not do. Actually our equation is sin IC is equal to N21 itself. That is the equation. But in the question they will be giving the refractive index of glass with respect to air. This equation is applicable for the refractive index of air with respect to glass. So that you have to keep in mind. Now we can check whether this will practically this is possible to do such an experiment, whether we can demonstrate this one. So for that one, what we have to do is we can take a beaker. We can take a beaker like this, and in this beaker, if you take some water, now we can send a beam of laser light to that one. If you send a beam of laser light in the light, the water, it will not be visible. So you have to mix something, just like you can mix the same chalk powder or soap or something, so that the entire clarity reduces little bit, means it will be visible. So what happens is when the light is standing like this, the light, one part will reflect like this, another part will refract in the normal condition. When the angle of angle will change, when it reaches to I greater than critical angle, this will go. Only this downward light will be there. That is, only you can see only the light which is coming down. That is, only reflection will take place. Refraction will not take place. That is, in total internal reflection, the internal reflection only will take place. This refraction will not be there. So internal reflection and total internal reflection are different. Internal reflection takes place in every case. Whenever light is passing from glass to air, what happens is one part of the light will pass through that one and another part will undergo internal reflection. It happens always. But in the case of total internal reflection, the refraction part is completely zero. The entire light is getting reflected back. That is the importance. Now, just I will demonstrate this one using the same method we will demonstrate. Now, as it is a daytime, the brightness, the external brightness is more, so it may not be that much clear, but even then if you closely observe, you can see the internal reflection in the beaker. Okay, now we will go to. Listen here, you can see a beaker of water. To reduce its transparency, I just mixed a little bit soap inside this one. Okay, so this is soap water. Now I am sending a beam of laser through this one. You can see on the wall one laser dot is there. So I am sending that laser through this one. You can see it is very clearly visible. From that water surface, it is reflecting back. if you notice here on the wall, you can see that spot down. See, it is not, when the angle is more than critical angle, you can see it is going down only, it is not going up. So here you can see clearly. Now once more you see the laser is getting totally internally reflected. It is not passing out. The laser completely getting reflected towards downside. So this is a best example for total internal reflection. If this total internal reflection is not taking place, means it should go straight to the wall. You see, it is not going to the wall. It is going down. Okay, otherwise it should go straight to the wall. It is going down due to total internal reflection. Okay, so when the angle changes, you can see it is going up also. When the angle is more than critical angle, it is going down only. Like this. So this is the total internal reflection. As beam of laser undergoing total internal reflection, you can see here. Okay, I think you already seen one example. There are so many examples like this. So many phenomena which is happening because of the total internal reflection. And another simple one I will tell you, which you may have noticed. For example, when you take some soft drink which is without color, just like the 7-Up, Sprite, such a thing which is without color, if you take that one and sometimes a small bubble in that one, that bubble will be in silver color. Actually, nothing is there with a silver color inside that one. What happens is their total internal reflection takes place. So this due to this total internal reflection, that bubble will be in silver color. There are so many other examples also, and there are some applications also. So we will discuss one by one. The first one is about the mirage, M-I-R-A-G-E. Okay, let's call us mirage. So mirage means it is a phenomena which it's an optical illusion actually. What is illusion means? Illusion means something which is not there, you are feeling it. You will feel it. In magic, we have illusion. Illusion means something which is not happening, but we will feel it is happening. So that's called as illusion. So mirage is an optical illusion, and opposite of this mirage, we have something called as looming also. So first we will discuss what is this mirage. This one you can see in different way. Mostly it is seen in the desert. So when somebody is moving in the desert, what is more important about this desert, the temperature near to the surface will be very high because of the sunlight. The surface temperature will be very high, and when we go up, the temperature reduces. So the refractive index also will be like that. The refractive index of the air near to the surface will be less, and when we go up, it will be more. The same situation will come in the highway also. If it is a long highway in a very hot day, and in the desert also, it works in the very hot day only. So you see here, if your surface is like this, and this surface is very hot, so that this area, this lower area is denser medium, and if you go up, the lower area is rarer medium, and when you go up, it is denser medium. You think the situation, here one person is standing here. Okay, a person is standing here, and here we have some tree, and now don't think that why there is a tree in the desert. It can be a cloud or any object. So the light which is coming from here, the tree or cloud, whatever is there, this is coming down like this. But what happens is, due to the change in the refractive index, it is coming from denser medium to rarer medium. So it will undergo total internal reflection. Not exactly from a point, slowly it will undergo total internal reflection. So that in each and every layer it will bend like this, and it will come to the eye of this observer like this. So the light is coming like this. And one thing is very important. Whenever we see light, we cannot see the light which is bending. For example, if one person is standing there, I am keeping a mirror here and looking at that person, I can see that person inside. Actually the light is bending like this, but I never see the bend. I will see the person inside here, because we will feel in our brain it is already written light is coming straight. So we don't have an ability to think that light is bending like this. Two people are standing here, you are seeing a person on the mirror, the person who is standing with you. You will feel that fellow as inside the mirror only. You don't have the ability to think that it is like this, he is here. You will see him inside only. So our brain is like that. So what happens is, this fellow, he is looking here, he is seeing the light here. So what he will feel? He will feel the light as coming from here. So instead of this tree or cloud, whatever is there, he will see another black image here. So saying because of our mental condition, mostly the people will be, they needs water in the desert. So they will feel it as water or some greenery, like that you will feel. Same thing you can observe in the highways also. When you are going in highway, if it is a very long flat highway, you can see some black patches. When you reach there, that black patch will not be there, that will be again. So this is what happens in the case of desert or highway. So this is a very good example of our total internal reflection. Here you have to remember the total internal reflection is not taking place in a particular instant, it is slowly bending. Another example also, if you take the case of diamond, you might have seen the diamond which is cut in a particular shape. The diamond rings and it will cut it in a particular shape. It will have a shape. Generally like this, they are cutting a diamond. They are cutting a particular shape. Now, what happens is the refractive index of diamond is, you know, it is very high, 2.4 that refractive index. When the refractive index is very high, the critical angle will be very less. So something like 24 degree is the critical angle for diamond. So if the angle is more than 24 degree, what will happen? It will undergo total internal reflection. And the diamond cutting is also done in such a way that when the light goes inside, if a small ray of light goes inside, it will undergo so many total internal reflection and it will come to some random unexpected side. That's why whenever you are looking at diamond, the light will be coming from that one and you will call it as the brilliance of the diamond. For the diamond we have a brilliance because of this one. What's actually happening? It is not producing any light. The light which is going inside, it will undergo multiple reflection, multiple total internal reflection, and it is coming out of a unexpected side. That's why we will feel a brilliance for that one or a shining for the diamond. So the brilliance of the diamond is because of this optical property, total internal reflection. Now you will understand what is the difference between a glass. If you cut a glass like a diamond, why it will not work? Because glass refractive index is 1.5 only, that is 2.4, so the brilliance will be more because more internal reflection will take place. So if you take a glass and cut like diamond, it will not become diamond. Okay, it's not because of the hardness, it is because of the refractive index. Diamond's refractive index is very high. So that is one, the second application of this total internal reflection. And one more we can use, that is we will use prism for different purpose. For example, in camera and in binoculars and all, to bend the light. See, actually when you are using the SLR camera, in the camera you are seeing the lens is here and your viewfinder is little bit up. So you have to bend the light like this. Okay. So there we can use mirror or we can use prisms also. So in the case of mirror, what happens is little bit light absorption and all will be there. But this total internal reflection, if you are making use, it is totally reflecting. There is no loss for light. So to bend the light, we will use prism. So we will think how we are using. For example, if you want to bend the light by 90 degree. So you have an object here. The light is coming from the object. You want to bend the light here like this. So what we can do is we can keep a prism like this. So that what will happen? It will go like this. It will undergo total internal reflection and it will come here like this. Okay. So your image is here. So you see here it is bending by an angle of 45 degree. Here means 45 it will bend by 90 degree. The light is bending by 90 degree. So whenever you want to bend light by 90 degree, we can use a prism like this. Okay. So the appropriate refractive index also you have to use. So for what refractive index it will bend and all such numerical problem is there. Previous Cbse examination problems you can check that. Now if you want to reflect back directly, you want to 180 degree you want to reflect. So there is another method for that one. You can see. If you use a prism like this, the light which is coming from here, see directly this will get inverted toward this side. Okay, you may feel this one as new, but you have seen this one in several times. I will give you the simplest example of this one. Behind your bike or cycle, we have something called as a reflector. If you have seen its broken light reflector, red color reflector, its outside will be smooth like this. Inside, if you check, you can see small like this triangle shape will be there. The working is same only. The each and every light ray which is going inside, it will undergo total internal reflection and it will come back. So the reflection, the reflectors of the vehicle will have backside red color light. Other than the light, some reflectors will be there. So when your vehicle light goes and hits there, it will reflect. So there we are making use of this type. This one I made big one like this. Small triangles will be there in that one. If you have seen some broken reflector, you can see some rough surface will be there. There is small triangles you can see. So that is another application. This is not the end. We have so many. In this triangle itself, we can use it for inversion of. Inversion means you are seeing an object, you are seeing it upside down. For example, you are using a telescope. You are using a telescope. In the telescope, you will see the image upside down. So for an astronomical telescope, you can see it upside down, no problem. If the moon is upside down or that doesn't make it a star. If it is up or down, it will not make it. But if you are using a terrestrial telescope, terrestrial means from Earth to one place to another place. There you have to invert once more. So there we will use a prism like this. Like this one prism can be used. So the light which is going from here. See here, this is very important how it works. Okay, this is coming here, going here. Now this becomes inverted. So see here, the one which is going on the top is reaching to the bottom. The one which is on the bottom is going to the top. Okay, in your textbook the same thing. This after cutting here they have done like this. That means the same only. Okay, the top part is not shown, so don't feel it as a different thing. That is a prism only. Okay, so this is used for inversion of the image. Like that, we have so many applications for this one. So these all are the old thing. Now in the new world, the most important thing is the optical fiber. You might have seen roadside something called as optical fiber. We will call it as OFC. Optical fiber cable. Reliance will be there, BSNL will be there, and even in your schools also you might have seen the optical fiber. See, generally like this cable will be there, optical fiber cable. This color generally they are using. So this is not the optical fiber full thing. Inside this one very small, even I can't show you, that much small fiber will be there. That is just like your hair. Fiber will be there, some transparent material fiber will be there. Through that one we can send the light. You can see here, if it is like that, if you send light here through this round it will go. So instead of communicating using a wire, we can use optical fiber. The advantage of using optical fiber is, in the optical fiber when we are using, you are sending light. In the normal wire we are sending current. When you are sending current, resistance will affect. But the optical fiber, resistance is not there because we are not sending light, and the external electric field, magnetic field, such a thing will not affect the light also. So you can send for, generally we are sending for 200 to 300 kilometer without any boosters and all. You know, even inside the ocean, from one country to another country, we are putting the optical fiber. So for this one, for kilometers, hundreds of kilometers without any amplifier, we can put the wire. Our normal wire is not like that. Normal wire means for each 1 kilometer we need an amplifier. Otherwise the signal will become weak because of the resistance. Everywhere you have to amplify it and send. But the optical fiber for 100 kilometer, 200 kilometer without any amplification we can send. That's why we are using the optical fiber. Okay, so that's the advantage of optical fiber. We are using light signal instead of electrical signal for communication. Now all your telephone communication, internet, everything is coming through the OFC only. Now you will think how the OFC works. So I am drawing a part of the optical fiber. It's a curved fiber. So this one what I am drawing here is, again you should remember, this is having the size of a hair only. Okay, just for you to understand the working, I am drawing it as big. Okay, this is less than 1 millimeter size only is there. So like this we have a plastic or not normal plastic, high quality plastic or the glass material which is transparent. And above this one we have another also. So we have two transparent material, one over the other. Okay, these two together will come less than 1 millimeter only. Okay, these two together will come something like a hair only. So just like a hair, very small thing, near more than 50,000 people can communicate at the same time through one wire itself. Even if you take higher bandwidth, you can communicate more than that one. Lakhs of people can communicate through this one. So this is having two part I told you. Okay, So the importance of this one is this inside we have N1, and if you take outside N2, the inside is high refractive index. This is the refractive index of inside is high and outside is low refractive index. The inside part with the high refractive index, that is called as the core of the cable. So this is called as the core, and this one is called as the cladding. Okay, so we have core and cladding, two parts there. Okay, one part is called core and another is called as cladding. So cladding is the outside part and core is the inside part. Okay, now how the light travels here? Same principle. You know the total internal reflection. If a ray of light enters here, it will undergo total internal reflection. So it will reflect here. Again it will undergo total internal reflection. Like that it will undergo multiple total internal reflection. So whatever way you are keeping it, you can send the light inside and then the light will come back also. Okay. This is used in many purposes. Wherever you want to send light, where actually putting a light is not possible, just like in the endoscopy or in some medical applications and some other place where we cannot take the source of light there. From outside you have to, in a pipe you want to take light up to there, means we can use this one. Okay, so that is the purpose of optical fiber, mainly used for communication, and it is again used for some other medical purpose and all. Okay. So this much is about total internal reflection. Total internal reflection is a very important topic and interesting topic also. So once you revise this entire thing and remember about the problem, that is when you are calculating the critical angle IC, sin IC is equal to refractive index. There refractive index is refractive index of the rarer medium with respect to denser medium. You should be very much careful in doing problems related to that one. So we will wind up, and the next class we will discuss about the refraction of by spherical lenses. Okay, we will discuss about the lens, and there are something called as lens maker's formula and all that we will do in the next class.